While degrees are based on some arbitrary number, so where we just say, well, we'll call a full revolution 360 and we'll chop it up into little pieces and each of those will be called a degree, with a radian we define the size of what a radian is by a particular circle in relation to a particular circle. And the particular circle that we're going to be working with is what's called the unit circle. And the unit circle is just a fancy way of saying the circle with a radius of 1 unit. Okay. And we define radians like this. Okay. Let's imagine that I'm just here on the edge of the circle, and I'm going to walk around the edge of the circle a distance of 1 unit. Okay, so if I got my tape measure out and measured around the edge of this curve here, that would be 1 unit. Okay. Now the fancy name, by the way, while we're talking about it, is for this curved distance is what's called an arc. So the distance from there to there, we've walked an arc of 1 unit around the edge of the unit circle. Now, if I walk this distance around the edge of the circle, I say that the angle at the center is 1 radian. Okay, if I walk 1 unit around the edge of the unit circle, the angle at the center is 1 radian, and that's how we define a radian. It's how big we say a radian is. We can make the radian any size we want. This is the relationship that we choose. We say that we've gone 1 unit. And there's going to be some nice results that we'll see later that will come out of the fact that we make these two things the same thing. Okay. A few things to note while we're defining the radian. Okay. A degree. Okay. Think about how big 1 degree is. 1 degree is not very big because we have to divide this whole circle up into 360 little parts all the way around, and each of them would be 1 degree. So 1 degree is very small. In comparison, 1 radian is quite large. So, I mean, this is roughly a radian. I haven't measured it, but it's roughly how big a radian looks. You can kind of see that a little over 6 of them fit into a full circle. Okay, so these units are considerably bigger measures of angles. So, if we wanted to measure normal, smaller, acute kind of angles, a lot of them, would be part of a radian. They're not going to even be a full radian. So it's just something to be aware of. And in a little bit, we're going to look at how to convert between radians and degrees. Now that we've defined exactly how big a radian is, it's worth just thinking about how the radian is going to relate to a circle. So here we have a regular circle. In fact, it's still the unit circle. Okay, it's got a radius of 1. Now, we already know if we were measuring in degrees that an angle all the way around a full revolution would be 360 degrees. And we've been working with those a lot ever since primary school, so we've got a good sense of, what a degree, what 360 degrees looks like. We kind of have it rammed in our head that 360 degrees is 1 revolution. Okay, but how big would it be in terms of radians? Okay, we've already defined the radian as being the size of the angle when we've walked 1 unit around the edge. So 1 radian is the angle at the center if we've walked 1 unit around the edge. But here, instead of walking 1 unit, we'll have walked the entire distance around the edge of the circle. So if we want to know how many radians there are going to be in a full circle, we need to find out, well, how long is this distance all the way around the edge of the circle? Because that is going to be the size of what a full revolution is. And to do that, we're going to have to think about our formulas back to do with circles from primary school and high school as well. So the distance around the edge of a circle which we would call the circumference C, is equal to 2 pi r. And remember, pi is just some number 3.14-ish. Okay, so the circumference around the edge of this circle is 2 pi r, and r is the radius, which is 1 because we're working with the unit circle. So it's 2 pi times 1, or just 2 pi. Now I could put that in, you know, it would be about 6.28-ish. I use an approximately equal to sign here. It'd be about 6.28. That's going to be the distance around the edge of the circle. So the distance all the way around there, there's a horrible messy line, but it's about 6.28 or 2 pi. Okay, which means that this angle at the center is the same. Because of the way we defined radians, where the distance we go around the edge is the same as the angle we've gone at the center, this distance of 6.28, 2 pi, means that the angle at the center is also 2 pi, or 6.28. So 1 revolution is equal to 2 pi radians.